Today, we're going to talk about nuclear energy, how it's produced, and the role it plays in our world. Nuclear energy is used worldwide in places such as homes, businesses, hospitals, and many other places. But how is it produced in the first place? Simply putting it, nuclear power plants heat water to a high temperature to produce electricity. The water is heated through nuclear fission, which we'll talk about later, and the steam created in this reaction then spins large turbines that generate electricity. Nuclear reactors mostly use uranium dioxide. Now we can bring it back to obtaining the uranium in the first place. The first step of the process is exploration, where uranium can be mined through heap leaching, drilling, open pit mining, and then finally, underground mining. The uranium is then transported and milled, where the ore is refined into uranium concentrate and then into a gas called uranium hexafluoride. After that, the uranium is converted into nuclear fuel through a reaction that turns the gas into a black uranium dioxide powder. The powder is then compressed into ceramic pellets, which go into rods to form fuel rods. Then, the rods are transported to the plant, where the rods are assembled together. Adding water to these rods initiates the nuclear reaction. However, after 30 years, these rods need to be disposed. They are put into containers and then buried underground, where they are monitored for years to come.
The Resource Conservation and Recovery Act is the public law that creates the framework for the management of hazardous and non-hazardous solid waste. It protects communities and resource conservation. To achieve this, the program ensures regulation, guidance, and encourages source reduction and beneficial reuse. Half a century ago, the San Onofre nuclear power plant was built, and it had over 2,000 employees and provided over 20% of energy of Southern California. It is now permanently closed and located between San Diego County and San Clemente. The two existing units were both shut down in 2012 due to safety issues. However, decommissioning San Onofre will take numerous years until the process is complete. In 2014, the Southern California Edison announced that decommissioning will take 20 years and cost $4.4 billion.
Now, let's switch focus to the effect of nuclear power on nature. What happens when nuclear power is not in our control anymore? Today, let's focus on three major nuclear disasters in the human histories. The first one is called the Chernobyl disasters. It took place in 1986 in the Soviet Union at the Chernobyl nuclear power station. When scientists were attempting a poorly designed experiment, the workers at Chernobyl nuclear power station shut down the reactor's power regulating system and its emergency safety system. However, the experiment went wrong and the chain reaction triggered a series of explosions in the power plant, causing large amounts of radioactive materials into the atmosphere. This meltdown releases several times more radioactive gas than the atomic bomb dropped on Hiroshima. After decades, millions of acres of forest were still contaminated. Next, it is the Three Mile Island. It is the site of a nuclear power plant in south-central Pennsylvania. On March 28, 1979, a mechanical failure triggered a partial meltdown at the 3 Mile Island. A large flammable hydrogen bubble formed inside the city. The cleanup took 14 years and about $1 billion, and that was why no new nuclear power plants have been built in the U.S. ever since. Workers eventually removed 15 tons of radioactive waste. And lastly, the most recent nuclear disaster took place on March 11, 2011 at Japan's Fukushima nuclear power plant. An earthquake of magnitude 9.0 and a 15-meter tsunami destroyed the power supply and the cooling of 3 Fukushima Daiichi reactors. All 3 cores largely melted in the first 3 days due to overheating. Evacuation were made 20 kilometers around the power plant after the first day.
The focal pricing of the nuclear plants includes capital costs and operational costs. For the capital costs, which cost quite a lot, and it includes site preparations, construction, manufacture, commissioning, financing a nuclear power plant, and also purchasing necessary equipment and hiring engineers and laborers. All of those turns out to be $9 billion. On the other hand, operational costs, which cost almost doubling the cost of the construction cost, which includes fuel and waste. It takes more money on the fuel for coal plants than nuclear. For the nuclear power plant cycle, it starts with mining, which we mine 60 million pounds of uranium per year, and each pound costs $30 to $50. then it goes to conversion and fuel fabrication. Then it's off the screen, but it goes to nuclear power plants, which use uranium to heat up the water and generate steam and create electricity. Then we recycle the material. Even though it is efficient, but we still create a lot of environmental issues.
Let's look at the science behind nuclear plants. First, let's go to fission, which is what nuclear plants are using today. Fission happens when a heavy nucleus, for instance uranium-235, when struck by a neutron, splits apart into lighter nuclei and releases energy. It also releases more neutrons, causing a chain reaction. Nuclear fusion is the opposite. Lighter nuclei, such as hydrogen, are combined together and heated at a very high temperature, releasing enormous amount of energy, but usually the reaction happens under a strict condition of 180 million degrees Fahrenheit and huge pressure. Unlike nuclear fission, raw material for fusion is relatively cheaper and more available. However, we also produce radioactive waste material along with fission. According to World Nuclear Association, 370,000 metric tons of heavy metal waste are produced since the beginning of nuclear production by fission. A better solution is fusion, but it has cost a lot. US has invested $25 billion, but it's still in the lab stage.